Okay, here's example 3 with intersections of intervals. So remember, an intersection of two sets is just the set of all the elements that are in both the first set and the second set. So if you intersect A and B, then your answer is the set of all the elements that are in both A and B. Okay, so example 3 here, let's say A is the interval from 1 to 4, like this, and B is the interval from 7 to 8, like that. So, and we want to find out what is A intersected with B. Okay, so we just do, we're going to approach this exactly the same way we approached example 1 and 2. So just start by drawing a number line for both of these guys and make sure we line them up properly and everything. So number line for both of these, make sure all the numbers line up. So 1 to 4, okay, so we'll put 1 over here. I guess we can put 4 over here. Okay, and then 7 and 8. So 7 and 8 are both further to the right. So 7 here, and then 8 over here. So yeah, not really to scale, but that doesn't matter. We just want to make sure we get the order right. So 1, 4, 7, 8 as we go from left to right. So that's all that really matters, is make sure everything lines up. Okay, so now what? Now we figure out, are they open, like hollow circles, or filled in circles, or what? So 1 to 4 like this, that means 1 is strictly less than x, strictly less than 4. Okay, so we talked a lot about that in a bunch of earlier videos. So strict inequalities correspond to these rounded parentheses, and that corresponds to open circles here. Okay, so we get the open circles on both, and then everything in between. Now what about down there, here? So from 7 to 8, it's actually the same thing, right? Rounded parentheses here, so it's 7 strictly less than x, strictly less than 8. Okay, so open circle here, and everything in between. Okay. Now what we do is the same thing we did in examples 1 and 2. We come down here, we draw a number line, and we look for the overlap. Okay, so let's zoom in a little bit. Where is the overlap? Well, as it turns out, there actually is no overlap, right? So we see here 1 to 4 is completely separated from 7 to 8. So there's this big gap in between them, completely separated, right? So there's absolutely no overlap at all. So there's really nothing to plot, right? There's no overlap, so we have nothing to draw in here. So that kind of makes us sad, but maybe not really, I don't know. Not really that sad. But anyway, the answer, so what does this mean? If there's no overlap, then what's the answer? So remember, we're talking about sets here, and our answer is nothing. Okay, we have nothing. There's nothing in common. There's no overlap. These two intervals, these two sets have no element in common. There's no element that appears in both of them. Okay, so there's nothing in common. So remember, if you're talking about sets and your answer is I have nothing, then that means the empty set, right? So really, A intersect B is the empty set. Okay, so let's maybe make that a little prettier. Get it kind of centered at least. So that's the empty set. Okay, and now that actually doesn't make us that sad, so we can get rid of our sad face here. So we're good. The empty set's not too bad. Okay, so that's our answer here, and that kind of jives up, that kind of lines up with what we talked about earlier. When you intersect two intervals, there are only 3 possible types of answers. An interval, a single point, or the empty set. So in example 1, we saw something like this. In example 2, we had something like this. Here's example 3, where our answer is the empty set. Okay, so when you intersect two intervals, or more intervals, but you can always think of them as intersecting like 2 at a time. We talked about that, that's one of the properties also. Anyway, when you do that, you're only going to get one of these 3 things, okay? An interval, a single point, or the empty set. Okay, so that's example 3 with intersections of intervals. And this is an example where the answer is the empty set, because there's no overlap here, okay?